All right, fifth graders, you little fifth graders. We're moving on with our electricity and magnetism unit, moving on to magnets and electromagnets. What will a magnet do? A magnet will pull some metals towards itself. Metals that contain iron, nickel, steel, and cobalt are magnetic. In other words, a magnet will pull them. Now, the metal has to be, or it has to contain, iron, nickel, steel, or cobalt in order to be pulled by a magnet. If it doesn't contain those metals, the magnet will not stick to it. It will not pull those metals. A permanent magnet will keep its magnetic field without the use of an electric current. Permanent magnets are used, so it's probably what you see most of the time when you see a magnet. They keep their magnetic charge, okay, without any electricity being applied to them. Magnets come in all shapes and sizes: round, flat, horseshoe, a bar magnet, rod. Magnets have a north pole and a south pole. Similar or alike magnetic poles repel, while opposite poles attract. So the north and the north and the south and the south, they will push away, they will retract, they will repel. But the north and the south, or the south and the north, they will attract. They will pull together. As you can see right here in this picture. Broken magnets retain a north and south pole. So if you break a magnet, it'll actually become two magnets. Every magnet has a magnetic field around it. It can be thought of as an invisible line of force running from the north end of the magnet to the south end of the magnet. So all magnets have a magnetic field around it that you cannot see. But you can see its results. Here's a bar magnet, and they sprinkled some iron shavings all around it, and you can see the results of the magnetic field here. The Earth is actually one gigantic magnet. Okay? The North Pole is actually the South Pole of the magnetic field, and the South Pole is actually the North Pole of the magnetic field. And this is how and why a compass will work, because of the magnetic poles of the planet. Uses for permanent magnets. Lots of tools are made of magnets. You see the screwdriver there. Tight sealed doors, a compass, and refrigerator magnets. Now, what is an electromagnet? An electromagnet is a device that sends electricity through a coil of wire to produce a magnetic field. This leads to a magnet that can be controlled or turned on and off. When an electric current is passed through a coil of wire wrapped around a metal core, a very strong magnetic field is produced. This creates a temporary magnet. So an electromagnet is a temporary magnet, not a permanent magnet. A temporary magnet must have electricity. The same with an electromagnet. Temporary magnets cannot maintain or cannot remain magnetized on their own. Okay, they need electricity. As soon as you cut off the electricity, the magnet will stop working. Here's a simple electromagnet that you can make at home. All you need is a battery, some thin copper wire, and an iron nail. and make this what you see here in this picture, and that nail will be able to pick up a metal paper clip or anything metal. For example, right here. Now, if you choose to put a rubber band on it, when you're not using the magnet, make sure you take the rubber band off and open up this circuit here, because the battery will get hot and burn up. Here's another example. And another example using a very big battery. And this is an electromagnet used in a junkyard to pick up metals. Uses for temporary magnets: doorbells, MRI machines, trains, lifting magnets, speakers, motors, generators, telephones all use temporary or electromagnets. The difference: a permanent magnet keeps its magnetic field. A temporary magnet only keeps its magnetic field while under an electric charge. Last but not least, have a nice day. So there you have it, boys and girls. Magnets and electromagnets, know what they are, know the difference, know all your test questions. Get that busy right now. And what is that? Get down.